we'll move to the next topic, that is relation. So relation, what is relation? First we will write all the definitions and after that we will discuss the example. So a relation are from a set, from a non-empty set. So something should be there. The set should not be empty. So a relation are from a non-empty set A to a non-empty set D is a subset of A cross B. And what is A cross B? Cartesian product. So in Cartesian product we are relating all the elements of set A to set B. But in relation what we will do? We'll write that element only in relation which satisfies the given relation. A relation will be specified. We have to write that element only, like we have to write ordered pair A comma B such that B is divisible by A. So we will select that elements only which will satisfy the relation. So that's why it is called a relation is a subset of A cross B. So we will write only that element which satisfies the given relation. So whenever we will complete our writing the relation, the second element, when we will write the ordered pair in this way, the second element is called the image of the first element. Clear? A relation R from a non-empty set A to a non-empty set B is a subset of A cross B. So in relation, we will not write all the elements of A cross B. We will write that elements which satisfies the given relation. So all of you write down the definition when we will describe the relation. So in that relation, we will write the ordered pairs. So in the ordered pair, normally we are writing A as the first element. So when we will write down all the first element in a set, again all the first element if we will rewrite in a set, that set is called domain of R. The set of all first element is called the domain of R. And in the same way, the set of all second element is called the range of R. So again what we are doing, we are defining a relation R from a set A to set B. So in that what we will do, we will write down the particular elements which will satisfy the relation. So written, after that what we will do, the set of all first element in that relation is called the domain of R and the second element is called the range of R. Obviously the second element will come from the set B, correct? So here, from which set to which set we are defining, that set is called the codomain of R. So if R is a relation from A to B, the set B is called the codomain of R. If I am defining R from set A to A itself, then codomain will be equal to the set A itself. So from here obviously we can say range can be a subset or it can be equal to the codomain because a range is coming from the second element. So if I am defining a relation R from a set A to set A itself, so you don't have to say in this way R is a relation from set A to A. You can say in this way R is a relation on A. So R is a relation on A, if we are saying, means that is clear. R is a relation from set A to A. So all of you write down all these definitions. In a relation R, the set of all first element is called the domain of R. Set of all second element is called the range of R. The whole set B is called the codomain of R. This one you don't have to write. This one just I have explained here. Then range is a subset of codomain. So range can be a proper subset or it can be equal to codomain. That's why equal to sign is written. And then if the relation R we are defining from the set A to set A itself, then instead of saying R is a relation from A to A, we can say R is a relation on A. Till here written. Now just write one more point and then we will discuss all the example. Now write continuously. If n of A is equal to m. N of A means number of elements in set A is equal to m. Number of elements in set B is equal to n. Then already we studied number of elements in Cartesian product will be equal to m into n. And now we will check what will be number of relations from A to B. How we define the relation? Relation is a subset of Cartesian product A cross B. And in first chapter we studied if a set A has n elements, then number of subsets of A, number of elements in the power set of A will be equal to 2 raised to n. If the set A has n elements, then number of subsets of A is 2 raised to n. In the same way, number of elements in A cross B is mn. So number of relation means we are writing the number of possible subsets of A cross B. So that's why number of relation from A to B is 2 raised to mn. Number of relations from A to B is 2 raised to mn. So these are the basic concepts which you should know. Now what we will do? We will check how we will define the relation, how we will write the domain, codomain, what are the different ways of writing it. So shall we move? Okay. So write down the first question. So this is the first question. In this question it is given. All of you write down the question. Set A is equal to 1, 2, 3, 4, 5. Set B is equal to from 3 to 12 elements are there. And the relation R. R is a relation defined from A to B in this way. R is equal to set of all ordered pair x comma y such that y minus 2x is equal to 0 and x belongs to A. The first element should be from the set A and second element should be from the set B. In all the question, this is common. You have to write all in all the question. Write the relation in roster form, write its domain, range and codomain. Also draw its arrow diagram. Now we will check how to do all these things. Question written. First what we have to do? We have to write the relation in roster form. In roster form what we are doing? Yes, we are writing the elements directly. We will write down the elements which satisfy the relation. At present it is given in the question, it is given in set builder form. We have to convert in roster form. So after writing the first element, the set of all first element is called the domain. Set of all second element is called the range. And R is a relation defined from A to B. So the second element, the second set is called the codomain. After that we will check how we will draw its arrow diagram. So till here the question is clear. Okay, so all of you, I am writing the relation here only. Okay, all of you write down now. If you want, you can simplify it more. Here, the relation is written y minus 2x is equal to 0. So you can rewrite in this way. Y is equal to 2x. Y is equal to 2x. So obviously we are knowing y is the second element. X is the first element in the ordered pair. So if you will check what is the meaning here. Y is equal to 2x. So y is 2 times x. The second element is twice the first element. So now we will start taking the elements. So first one, x is equal to 1. So if x is equal to 1, what will be the value of y? 2. But 2 is not there in the set B because the second element should belong to set B. But we don't have 2 in the second element. So 1, 2 we cannot write. Now what we will do? We'll take the second element of the set A, that is 2. So if x is equal to 2, y will be equal to 4. 2 into 2, 4. 2, 4, both. 2 belongs to A and 4 belongs to B also. Now we will take x is equal to 3. Then what will come? Y is equal to 3 into 2, 6. And 6 is there in B. So we can write 3, 6. Next substitute x is equal to 4. What will come? 4 into 2, 8. And 8 is there in B. So 4, 8 also we can write. Then x is equal to 5 and 5 2s are 10. 10 is there in B. So we will write 5 comma 10. Now we don't have any element to take from the set A. So this is our relation. R is equal to the relation we defined. So only that elements which satisfy the given relation will belong to relation. Is it clear how to write down the elements? Okay. Now all of you write down domain. Domain of R. As according to the definition we wrote there. Domain means it is the set of all first element. So first element here 2, 3, 4, 5. So that will be the domain. 2, 3, 4, 5. In the same way, now what we will write? Range. Range of R is equal to range, collection of all second element in the ordered pair. So that will be equal to 4, 6, 8, 10. So domain over range over, and writing the element in this way. When we are listing the elements, that is called roster form. So already we wrote roster form, then domain written, range written. Then what we have to write? It's codomain. Codomain. Definition we wrote there. If R is a relation from A to B, from which set to which set we are defining, that is called its codomain. So codomain will be equal to set B. And what is left now? Yes, we have to draw its arrow diagram. Now we will check how to draw the arrow diagram. So to draw the arrow diagram, what we have to do? We have to list the elements of A and B. So I am writing the elements of A here, and B, I will write it shortly, B here. So set A, set B. So in set A we have 1, 2, 3, 4, 5, and set B we have 3, set B from 3 to 12. So I am rubbing this one, Set B 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we will check how to draw the arrow diagram. For that you just have to check the relation. 2 is related to which element? 2 is from set A and 4 is from set B. So how we will write here? 2 is related to 4. In this way you have to draw the diagram. 2 is related to 4. Then 3 is related to 6. 3 is related to 6. Then 4 is related to 8. 4 is related to 8. 5 is related to 10. So in this way, this is the arrow diagram, diagrammatic. This is the visual representation of relation. So from this it is clear. If you have to write, suppose arrow diagram is given and it is asked, write down the domain and range. So domain obviously clear. From the set A, 2, 3, 4, 5 will be its domain, and it is related to which element? That is called its range. 4, 6, 8, 10. And codomain will be equal to the whole set B. So it is clear how to find the domain and range, codomain, and how to draw the diagram. Okay, so all of you, in rest all the questions we will do all the things. Now I will define the relation only. Again and again I am not writing. Write down its domain, codomain, range, draw the diagram. We will draw directly. So all of you, the second question, in the second question set A is given and relation is given in this way. R is equal to set of all ordered pair x comma y such that y is equal to x square, x comma y belongs to A. So this relation is from which set to which set? The first element also belongs to A. The second element also belongs to A. So it is R is a relation on A. On A means R is a relation from A to A itself. Now what is the relation given? Just to check the meaning. Y is equal to x square. Y is the second element. Second element is the square of the first element. So shall we start writing? So this will be the roster form. So first we can take x is equal to 1. Okay. Then what will be the value of y? Y is equal to 1 square. So that also will be equal to 1. Then we will take x is equal to 2. Then what will come? Y is equal to 2 square. So that will be equal to 4. Then we will take x is equal to 3. Then what will come? Y is equal to 3 square, 9. Then we will take x is equal to 4. 4 square is 16. But 16 does not belong to A. So we cannot take x is equal to 4 here. So this is the set we got. The ordered pair which satisfy the given relation. So relation written means we wrote in roster form. Now we will write its domain and range. What will be the domain of R? Yes, collection of all the first elements in the ordered pair. So 1, 2, 3. It's domain. And what will be the range? Second element. Set of all second element is called its range. What will be the codomain? R is a relation from A to which set? A to A only. So codomain will be equal to set A. Now one more thing we have to do. What is that? Yes, arrow diagram. So we will draw the diagram here. R is a relation from A to A only. So set A. A, here also it is A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now define. Draw the arrow diagram according to the relation. 1 is related to 1 only. 2 is related to 4. And 3 is related to 9. So in this way we will draw the arrow diagram. This is clear to you? Clear? Okay. So we will move to the next question. Next, already written there, define a relation R on the set N of natural numbers. So we have to define the relation on the set N. Meaning from N to N itself. R is a relation. R is a relation from N to N, and relation is given in this way. Both x comma y should belongs to natural number. X is less than 6. So x is a natural number which is less than 6. And second element y is equal to 2x minus 1. So first we will write down the relation in roster form. So x is a natural number less than 6. So first we can take x is equal to 1. What will come? Substitute here. If x is equal to 1, y will be equal to 2 into 1, 2. 2 minus 1, 1. So first one will come 1 comma 1. Then if x is equal to 2. If x is equal to 2, what we will get? Y. 2 into 2, 4. 4 minus 1, 3. Then if x is equal to 3, then what will come? 2 into 3, 6. 6 minus 1, 5. Then if x is equal to 4, then what will come? Y? Yes, it will be equal to 7. Then x is equal to 5. Then y will be equal to 9. X is equal to 6 we cannot take because it is written here x is less than 6. So this is our relation. So again we will write down the domain. Domain means collection of all, set of all first element. So that is 1, 2, 3, 4, 5. Range will be equal to, range is equal to 1, 3, 5, 7, 9. What will be the codomain? Yes, codomain will be equal to the whole set N, set N of natural numbers. Now we will draw its diagram, arrow diagram. Shall I rub this one? You all wrote? No, this one I am not rubbing. Domain and range I am rubbing. So now here we have set N of natural numbers. So N, and here also we are writing N. So some numbers I am writing here. 1, 2, 3, 4, 5, 6. It is infinite here. Here also 1, 2, 3, 4, 5, 6. This one if you want you can define. It is written it is less than 6. X is a number less than 6 it is written. About y they haven't written anything. They just define the relation. Or if you want, we know these many elements will be there. So till there we can write 5, 6, 7, 8, 9. So first one. 1 is related to 1. 2 is related to 3. Then 3 is related to 5. 4 is related to 7. And 5 is related to 9. So this is the arrow diagram. So I think this concept is clear to you. Okay. So write down the next one. So all of you, in this question it is given set A is equal to 1, 2, 3, 5. B is equal to 4, 6, 9. The relation is defined in this way. Set of all ordered pair x comma y such that difference between x and y is odd. X minus y or y minus x should be an odd number. First, x we have to take from A and y we have to take from B. So shall I start writing the elements directly? Okay. So first one. 1. 1 minus 4. What will be 1 minus 4? Yes. Minus 3 or 4 minus 1. Which one you want? X minus y should be odd or y minus x should be odd. 1 minus 4 is minus 3 and minus 3 is an odd number. Yes. So 1 comma 3 will be in the set. Then next 1 comma 6. Again 1 minus 6 minus 5 odd number. So 1 comma 6 also will be there. 1 comma 9 also will be there. 1 minus 9. 1 minus 9 is minus 8. No. So 1 comma 9 will not belong to the set. The second one we have to take from here. So from 1 it is over. Now next we will check with 2. 4 minus 2. 2. Not an odd number. So 2 comma 4 will not come. 2 comma 6 will come. 2 minus 6 is minus 4. No. Then 2 comma 9. Yes. 2 minus 9 is minus 7. So 2 comma 9 will belong to this set. Now we'll check with 3. 3 minus 4 minus 1. Yes, odd. So 3 comma 4 will come. 3 comma 6. 3 minus 6 minus 3. Yes, odd. So 3 comma 6 also will come. Then next 3 comma 9. 3 minus 9 is minus 6. No. So 3 comma 9 will not come. Then next 5 comma 4. 5 minus 4, 1. Correct. So 5 comma 4 will be there in this set. 5 comma 6. 5 minus 6 minus 1. Yes, odd. Then 5 minus 9 minus 4 even. So 5 comma 9 will not come. So these are our elements of the relation R. Now we will write down the domain. Domain will be equal to 1 we have, 2, 3 and 5 we have. So we have all the elements 1, 2, 3, 5. Then range is equal to the second elements. Just to check, we have 3 here, we have 4, 1 comma 4 will come here, not 1 comma 3, 1 comma 4 because the second element will belong to set B. So 1 comma 4, 1 comma 6 in this way we have. So we have 4, 6 and 9. Repetition we don't have to write it 2 times. So range also whole set B there. And codomain. Codomain obviously we are defining the relation from A to B. So codomain will be equal to B. Now we will check how to draw the arrow diagram. Arrow diagram I am drawing here only. Set A, set B. Set A, set B. In set A we have 1, 2, 3, 5 and set B we have the element 4, 6, 9. So first one. 1 is related to 4, 1 is related to 6 also. So 1 is related to 4 and 1 is related to 6 also. Then 2 is related to 9. 2 is related to 9. 3 is related to 4 and 3 is related to 6 also. Then next 5 is related to 4 and 5 is related to 6 also. So in this way we can draw the arrow diagram. So I think this concept is clear to you. So all of you please note down your homework. These questions are simple there. That's why 2 exercise I think you can finish. Your homework will be equal to exercise 2.2. So exercise 2.2 you can do. In that question number 3 we have discussed in the class. So except question number 3, rest all will be your homework, and do the homework, and in case of any doubt, please ask the doubt. Thank you.